So the last concept is solubility of molecular compounds. So we've discussed when we reviewed the stuff at the beginning of the semester about solubility. We talked about solubility of ionic compounds, but here in the bonding unit, we need to touch base on how are molecular compounds' solubility determined. And the way that we determine it is really actually quite simple. It's from this one statement right here, which is like dissolves like. What this essentially means is that polar substances can be dissolved in other polar substances, or non-polar substances can be dissolved in other non-polar substances. But the minute that you try to mix the two, there's no solubility that happens. So for example, hydrochloric acid will dissolve in water, and it's because both of these substances are polar substances. But if you've ever been at the lake before and dad or grandpa or uncle's been filling up the boat with his jerry can and a little bit of gasoline spills on the water in the lake, C8H18, that's gasoline that we use in our vehicles. This is a non-polar substance if you draw it out and take a look at the electronegativities, and this non-polar substance cannot dissolve in water, and this is why the gasoline just kind of sits on top of the water. You've also seen probably in elementary school the demo of the oil mixed with water. You try and mix it together and then the oil and water separate. The reason that they separate is because cooking oil is a non-polar substance and can't dissolve in water. This is a concept that we've actually taken a little bit further in science in terms of like dish soap. So dish soap kind of solves this problem if you've ever gotten butter on your hands or grease from doing the dishes, or you're trying to clean dishes that have a lot of grease on them. The grease and the oil that comes from certain foods is non-polar and can't dissolve in water. And so if you've ever tried to wash that off using just water, it's quite impossible. And when you use the soap in doing the dishes, what that does is you have a soap molecule that's actually quite long. So it's this really long chain of carbons, and on one side it's non-polar on one end of the chain, and on the other end of the chain it's polar. And so what makes soap kind of cool is that when you dissolve grease, for example, using soap, the grease will attach itself to the non-polar end of the soap molecule, and the water will attach itself to the polar end of the molecule. And so you get this molecule that can kind of act as a bridge between two substances that otherwise wouldn't attach themselves together, and you can clean these things quite easily. And so this is why solubility is important, and here's some concepts that we learn as we understand the solubility of things. And you will be asked simple questions in terms of what is the solubility of certain substances in water or other substances, other solvents that may be non-polar. And so like dissolves like, that's what you want to focus on.